Welcome to my presentation. In this paper, we will study the intelligent learning systems for the environmental factors that affect the distribution of some leishmaniasis vectors. So, normally, this is the thesis of a student actually, and we try to improve it by adding some intelligent learning system to it. So the outline is as follows: introduction, problem statement, proposed solution, image database, sample image from the fly actually, proposed solution, results and conclusions, and future work. Leishmaniasis is a disease that affects humans, canids, rodents, and vertebrates. It is caused by different species of Leishmania protozoa with tiny sandfly insects as the incriminated vector of the disease. Some cases of the disease require treatment, while in other cases, if left untreated, can lead to the death of the affected victim. So we propose a solution here. Artificial neural networks is a quite accomplished problem-solving approach in computing and information technology-oriented devices. In this paper, we choose backpropagation neural networks, which is one of the machine learning algorithms. It is applied in recognizing some vectors of leishmaniasis using some environmental factors. So we have the numerical database used here, because we can use image database as well, some numerical values as well in decision or categorization purposes. In this one, we have 9 species of leishmanias with 6 factors that possibly affect their abundance. So this is a sample image from the fly, from the animal, which creates this problem. And when I made some research about it, it is mostly seen in South America and Africa. And there are 9 types of leishmania, which are given here on the slide. And there are 6 conditions which affects that fly to live actually in that field, in that area, which are population density, active temperature, humidity, rainfall, altitude, and vector abundance. Machine learning is a field of study that gives computers an capability to learn without being explicitly programmed. Machine learning is one of the most exciting technologies that one would have ever come across. As it is evident from the name, it gives the computer which makes it more similar to humans. So we use machine learning actually to make a PC, to make a computer, think like a human brain. So we try to teach computer what our thoughts. So at the end of the day, we ask the computer to give some decisions. Okay? So backpropagation neural networks has been preferred, which is one of the machine learning algorithms, due to its simplicity, easy to implement, high accuracy, and it is the basis of deep learning neural networks. Here we have the architecture, and 6 environmental factors are given, and 9 types of leishmaniasis. And there are 6 inputs, 9 outputs. Hidden layer is 15. It is hidden layer and the other rates given below has been decided after several trials and several experiments. And here we can see the RMS error graph. So initially when we teach something to a PC, initially as human beings, it cannot learn it well. But as we increase the number of iterations, we can see that the graph scrolls down. So in this paper, we used 45 training and 180 testing attributes. And when we tested our system with 180 testing attributes, 169 of them was correctly recognized. So it means that this system is applicable on deciding or categorize in the categorization field. So the future world will include the increment of data for existing study. There are, I told you, many other types of machine learning algorithms, and the other algorithms can be checked as well in order to increase the accuracy, actually. And we can improve the database to check other types of leishmaniasis, or we can, if we have a data in our hands, we can try to include them in order to give more categories of problems of these flies. Thank you.
I like this, when people really respect the time, because the time is running from us. Is there any question, because this is really quite interesting, intelligent learning system. I like also very much this topic. Any question?
Only we need the database.
Yeah.
If we have a database, not the human beings, but we can make the machine think like a human being,
yeah,
and give some decisions. So if you have the database from other,
and you get the result, yeah,
other, processes, other things, then we can try to get good solutions.
Thank you for your presentation. The number of training data that you used was 45, but the validation was 180.
Yes.
So how did you test that? Your network is not overfitted to the training data.
I didn't get the question. Can you repeat?
The number of training data is very far less from the
Okay.
validation data.
Normally we keep the training data low, and we keep the testing data more, actually. And we try to train it with little data and ask many questions to.
Yes. But there's one dangerous part that can be overfitted to the training data. Because the number is very low, it's will be overfitted, so it will just learn the training data and will again give you the training data as a result, but not predict it.
It can really improve later.
What about the students? Because it is their time, using artificial intelligence and other algorithms. Probably in undergrad, we don't have so many lecture hours for
This course?
for the
This course is mostly computer engineering.
yeah,
or
computer engineering, maybe, yes.
some other departments.
Yes. Okay. Thank you very much indeed. Thank you.